Welcome to the DemandUp application tutorial. In this video, we will explore the functionalities that drive strategic demand planning, providing a clear and structured approach to optimize processes and decision-making. To facilitate understanding, we have organized the content into 7 fundamental blocks. 1. Version management. Versions are essential for managing planning scenarios, comparing data, and analyzing projections. We will explore how they interact with models of information within the tool and the options available to maximize their application. 2. Demand determinants variables. Quantitative and qualitative indicators that influence demand volume, seasonality, and patterns are critical for supporting predictions and enhancing their accuracy. We will demonstrate how DemandUp enables mapping, projecting, and leveraging these variables for more precise forecasts and strategic decisions. 3. Marketing actions. Comparing the performance of planned versus executed marketing activities is vital for assessing campaign effectiveness and making swift strategic adjustments. We will show how DemandUp supports the planning and monitoring of these actions, delivering valuable insights. 4. Target market. A comprehensive view of the target market enables more accurate forecasts, efficient segmentation, trend anticipation, and resource optimization. We will present how DemandUp provides detailed analyses to support agile responses to market dynamics. 5. Prediction. Leveraging artificial intelligence and machine learning, DemandUp empowers leaders to not only anticipate the future but also shape it. We will explain how to operate these functionalities for innovative and proactive demand planning. 6. Data locking. The data locking functionality, integrated within SAP Analytics Cloud, ensures security, control, and data integrity, particularly in collaborative environments. We will explore how this feature safeguards data and maintains planning reliability. 7. Analysis. DemandUp's analytics layer offers intuitive visualizations, including charts, maps, and tables, for a rapid understanding of business scenarios. We will explore the presentation tools that transform data into strategic decisions. By the end of this tutorial, you will have a clear understanding of how these blocks integrate to enhance demand planning, driving efficiency and results. Let's get started. In DemandUp, aligning versions across models of information is a critical practice to ensure consistency in demand planning. As SAP Analytics Cloud employs specific versions for each model of information, ensuring that a single version code represents the same business scenario across all models is essential. This enables data to reflect a unified scenario, regardless of the model accessed. To implement this practice effectively, 3 key considerations guide version management in DemandUp. 1. Models requiring alignment. The demand determinants, market metrics, marketing plan, and sales plan models must keep their versions synchronized. This alignment ensures data coherence and supports integrated analyses, which are vital for strategic decision-making. 2. Sales prediction model. The sales prediction model serves as a dedicated workspace for prediction procedures. Due to its technical design, it supports only 2 versions, actual and forecast. This limitation simplifies usage, focusing on generating accurate predictions. 3. Target market model. The target market model stores configuration data, including relevant items and versions from the sales plan model accessed via the target market planning interface. It plays a supportive role, organizing information for market analyses. Let's now explore the DemandUp interface in greater detail. Upon selecting a report and clicking the Version Management button, the system displays a dialog box identifying the active model of information. From this point, all functionalities are provided directly by SAP Analytics Cloud, following an intuitive standard that simplifies version handling. Returning to the DemandUp interface, it presents the data volume for each model of information, broken down by version. This feature is particularly valuable for maintenance tasks, such as database cleanup, enabling the efficient removal of unnecessary information. Demand determinants are factors that influence the quantity demanded of a good or service. In DemandUp, the values of these variables are determined based on specific contexts, integrating elements such as customer, customer group, product, and product group. But how does DemandUp determine a variable's value? The system employs an intelligent search strategy, evaluating contextual element combinations hierarchically, from the most specific to the most generic. The search concludes once a matching value is identified, ensuring precision and alignment with the context. Let's go to practical example. The weather factor variable has a default average value. When the context is adjusted to specific regions, the system displays customized values, reflecting the unique characteristics of each scenario. And how are values recorded in the system? DemandUp enables the recording of variable values across different contexts, building a robust data foundation. To streamline the creation of this database, the system offers the Upload Files feature. This tool allows data to be uploaded via spreadsheets formatted according to the transaction's specified layout, covering all relevant contexts. Additionally, the platform provides an interface that delivers a comprehensive overview of all contexts associated with a variable, simplifying data management and analysis. Marketing actions serve as powerful strategic tools that connect companies, brands, and products with their target audiences, driving objectives such as customer attraction, engagement, and loyalty while reinforcing market presence. Within the context of demand planning, these actions play a pivotal role, directly influencing projected demand volumes and expected outcomes. DemandUp leverages both real and planned marketing action data to deepen insights into demand behavior. By integrating this information, the system not only enhances predictive analytics but also enables a comprehensive evaluation of the impact of marketing initiatives on achieved results. This provides actionable insights that empower informed decision-making. Featuring an intuitive and highly functional interface, DemandUp allows users to accurately associate marketing action volumes with their scope of influence. The system seamlessly integrates contextual elements such as customer, customer group, product, and product group to map and address the reach of each initiative. This ensures strategic alignment and granular analysis, optimizing the effectiveness of marketing efforts. To accelerate the development of a robust data foundation, DemandUp offers the Upload Files functionality. This tool enables efficient data uploads through pre-formatted spreadsheets, covering all relevant contexts of marketing action influence. By simplifying the data input process, it frees up teams to focus on strategic analysis and decision-making. Furthermore, the platform provides a consolidated and structured interface that offers a comprehensive view of all contexts associated with marketing actions. This functionality streamlines management, monitoring, and performance evaluation, empowering businesses to refine their strategies and maximize return on marketing investments. The DemandUp Target Market interface streamlines demand planning by filtering the sales database with specific parameters. This functionality consolidates all relevant target market data into a unified view, optimizing planning, forecasting, and performance tracking. The initial interface provides a comprehensive overview of demand, offering comparative analyses across versions and diverse market perspectives. A key feature is the geo-referenced visualization through interactive maps, enabling detailed navigation via the drill-down function, which enhances market insights. In the planning interface, actual and planned data are presented in a single view, with market metrics available for manual adjustments or import through the Upload Files feature. This import process uses structured spreadsheets, with the layout documented within the interface, ensuring speed and accuracy. Demand-determining variables are displayed in the context of the target market, with the option to add parameters for impact simulations. Notably, during the forecasting process, these variables are calculated hierarchically, from the most specific to the most generic level, ensuring precise and contextually relevant results. The interface also enables visualization of marketing actions linked to the target market, with values shown individually and in aggregate. This hierarchical structure simplifies the analysis of volumes, timelines, and impacts of implemented initiatives. For demand plan creation, the interface supports manual data entry with dynamic interaction across sales organization, customer, and product hierarchies. Changes at aggregated levels, such as adjustments to planned volumes, automatically cascade to detailed levels, with a modification history available for review. the aggregated view interface is ideal for large-scale adjustments. A single change can redistribute demand volumes across the entire model, simplifying the management of complex data. To expedite database creation, the Upload Files feature allows spreadsheet imports, provided they adhere to the predefined layout. Additionally, DemandUp offers automated forecasting and version copying options, ensuring process flexibility. In summary, the DemandUp target market interface integrates data and tools to provide a strategic view of the business landscape, delivering solutions that simplify planning and maximize operational efficiency. Let's explore the prediction process. The demand forecasting solution is built on two core components of SAP Analytics Cloud: predictive scenario and multi-action. These components are designed to process a single target market at a time. To begin, we will activate the command to add a predictive scenario in the environment. Select the time series forecast option, choose the folder where the component will be stored, and fill in the name and description fields. In this case, we will name it Predictive Scenario Tutorial and assign the code Tutorial 01. Next, we will configure the scenario parameters. Description: target market, BR, coffee, north. Data source: our model, sales prediction. Version: train the model using the actual version. Target measure: always select value SD. Target account: always select sales quantity. Date: the model's time dimension is date. Number of forecast periods: 12 periods. Entity: dimensions considered for combinations are customer, product, and target market. Entity filters: restrict processing to the target market, Brazil, coffee, north. Train using: use the entire available dataset to train the algorithm. Until last observation. Yes, convert predicted negative values to 0. Influencers: always use predictive influencer as an indicator, combined with the following items: shelf space, price, degrees, infomercials, and rate. Once configured, simply save the scenario to complete the process. To reuse the same settings for processing another target market or the same market with additional filters, you can duplicate the model using the duplicate functionality. With the predictive scenario properly configured, the next step is to prepare the multi-action. Let's get started. Create a multi-action using the model provided by the application as a reference. To do this, use the copy function and name the multi-action as Tutorial 01 with the description Multi-Action Tutorial. Done. Now, let's replace the predictive scenario, then, select the fourth step of the multi-action and replace the parameters. Step name: Prediction Tutorial. Predictive Scenario, Tutorial 01. Predictive Model, Target Market, BR, Coffee, North. Predictive Action, Train and Forecast. Corresponding Planning Model, Sales Prediction Model. Save Forecast Version, Forecast. Do not enable the remaining options. Save the configuration. Now, let's configure the calendar functionality to perform demand forecasting procedures. We are creating a multi-action task named Run Prediction. Additionally, we will schedule its execution time. The task parameters configuration has the following variables. Description: Run Tutorial 01. Execution schedule: retain the pre-selected schedule. Multi-action: assign the multi-action to be executed in this task. It's Tutorial 01. Let's understand the parameters of multi-action. Sales target version specifies the version of the sales plan model where the forecasted demand data will be stored. We will use the MRF version. Sales source version defines the historical data source for demand. We will use the actual version. Synthetic source version indicates the version containing synthetic data. If synthetic data is not being used, you may use the same version as specified in sales source version. Metrics plan version determines the version of planned data for market metrics. we will use the MRF version. Demand Determinants Plan version, for planned data related to demand determinants, we will use the MRF version. Marketing Plan version, for marketing action planning, we will also use the MRF version. Number of forecast periods must match the value used in the predictive scenario configuration, in this case, 12 periods. Cutoff date, the last period with actual data in my database is December 2022, meaning this configuration is set to generate a demand forecast for the year 2023. After these settings, save the schedule to complete the process. Activities scheduled through the calendar functionality can be tracked conveniently and efficiently. The system sends automatic update messages, or you can access the Job Monitor, a dedicated tool that provides comprehensive details about the ongoing procedure. In this tutorial, we review the data related to the execution of the multi-action configured in the calendar. Monitoring occurs in real time, but in this case, the task has already been successfully completed. Upon exploring the log details, we find three main information blocks. Execution status displays the completion time and processing status, providing a clear overview of the outcome. Processing steps details the steps configured in the multi-action, including data on volume, execution time, and the corresponding status of each step, presented accurately and organized. Multi-action parameters lists the parameters defined for the execution, which determine the procedure's scope. In summary, the log serves as a complete record of the execution, consolidating all necessary information for detailed technical analyses of each performed procedure. This functionality ensures transparency and supports subsequent evaluations. By registering the link of the predictive model in the target market's master data, you can directly access the performance analysis of the forecasting procedure from the target market planning interface. The SAP Analytics Cloud uses the MAPE, mean absolute percentage error, as the standard metric to measure the accuracy of the forecasting model. While there is no strict universal standard, MAPE interpretation typically follows this widely accepted classification. Below 10%, excellent. Between 10% and 20%, good. Between 20% and 50%, acceptable or reasonable. Above 50%, poor. Upon reviewing the global performance indicator, we observed that the model's accuracy reached a significantly high level. However, the system issued messages recommending a larger volume of historical data to further enhance the reliability of certain forecasts. A more extensive dataset would enable the model to identify cycles and seasonal factors with greater precision. Moving to the individualized forecast analysis, it is possible to view the month-by-month projection details and identify the contribution of influencing factors to the forecasts. Additionally, the system provides detailed explanations of the individual forecasting process, highlighting details of the time series, impacts of influencing factors, identification of the cyclical demand component, and information about the algorithm's training process. These features offer a comprehensive and clear view of the forecasting process. The data locking functionality in SAP Analytics Cloud safeguards data against unwanted changes. To streamline visualization and expedite analysis, DemandUp consolidates statuses within a specific transaction, enabling quick scenario recognition and necessary interventions. The interface is organized by information model, with subdivisions by version and date, ensuring clear and structured navigation. To configure protection, place the cursor on a cell in the interface and access the Manage Data Locks feature via the context menu. This allows you to easily set the desired protection scenario. It's important to note that once a dataset is protected, planning users will be unable to modify it. This feature is particularly valuable for preserving actual data or planned versions, such as budgets, forecast revisions, targets, and more, ensuring their integrity. In the analysis layer, DemandUp leverages the power of SAP Analytics Cloud to explore the solution's databases. This enables greater freedom to navigate through information, facilitating a detailed and in-depth understanding of the business scenario. The solution offers significant versatility through pre-configured interfaces designed to support the planning process and provide simplified initial analysis. Charts and tables with active drill-down functionalities enable autonomous navigation, empowering users to explore data intuitively and efficiently. The Data Analyzer component provides a highly autonomous way to explore the database. It allows the creation of queries in tabular or graphical formats, giving users complete freedom to design reports at aggregated or detailed levels, tailored to their creativity and needs. SAP Analytics Cloud introduces an advanced generative AI feature through the Just Ask component, which responds to questions posed in natural language. For example, we can ask the system, "What is the sales volume for the MRF version in the months of 2023?" Alternatively, we can use a direct command, such as, "Summarize MRF version sales volume by sales organization." SAP Analytics Cloud delivers numerous benefits that enhance DemandUp's capabilities, seamlessly integrating advanced analytics, strategic planning, and data intelligence. We've reached the end of this tutorial, where we explored the key functionalities of DemandUp integrated with SAP Analytics Cloud. Throughout the content, we covered version management, critical for preserving the integrity of data across various business scenarios. Demand determinants, we detailed the procedures for planning these key variables. Marketing actions, we discussed the concepts and processes for planning marketing initiatives. Target market, we explained how planning is structured based on the target market. Prediction, we demonstrated how to operationalize the forecasting process and evaluate the quality of the results. Data locking, we explored how to secure data for a specific scenario, ensuring its protection. Analysis, we highlighted how SAP Analytics Cloud enhances DemandUp's value through an advanced and intuitive analytics layer. We hope this tutorial has provided a clear and comprehensive overview of the capabilities of the DemandUp solution. Until next time.